because today we are finally going to actually solve log equations. So the last couple of days we have been working on the background knowledge that we're going to need in order to solve these equations. We have been working on these properties on the last two worksheets, and now we're going to solve log equations using the law of equity. Does it make sense if you have a log equal to another log, if the base is equal, this part, the x has to equal the y. The logs are equal, the x has to equal the y. That is the property we are going to use on example number 1. Would you please look at example number 1? Now, in order to use this law of equity, we need one log on the left and one log on the right. But we have two logs over here and two logs over there. That's where we're going to use the condense property that we did yesterday. So this will change into log base 2 of 3x. How did that happen? The condense rules say that addition changes to multiplication. Over here, you have this 2 out in front of the log, so it needs to become an exponent. And so this is equal to log base 2 of 3 squared. Now this is what I did first period. Is that correct? What's supposed to be right here? Addition changes to multiplication. What is 3 squared times 5 equal to? This is equal to that. So this has to equal that in order to have an equality. The 3x has to equal 45. Can you solve that for x? X is equal to 15. That is how you solve a log equation where you have a log on both sides of the equal sign. So in example number 2, the first thing I need to do is something with this number out in front of the log. Using the power rule, this becomes an exponent. So we have log base 2 of 27 equals log base 2 of x to the 1/3. Since this is equal to that, the 27 has to be equal to x to the 1/3 power. Now, I'm solving for x, so I have to get rid of the 1/3 power. How can I get rid of a 1/3 power? Nope. I need to do what? Not times 3. I need to raise it to the reciprocal power. What is the reciprocal of 1? So I need to raise this to the 3rd power, not multiply by 3, not cube root it. I need to multiply it, raise it to the 3rd power. That will cancel out. And so x is going to be equal to 27 raised to the 3rd power. 27 raised to the 3rd power is a fairly large number. What large number? 19683? Why is it such a large number? That's 27 times 27 times 27. That's what it means when you raise it to the third power. Do you understand how I got this 3 right here? That is the reciprocal of 1/3, and that will cancel out the 1/3 power. When we are solving a log equation and we have logs on both sides, I need to condense so that I have a log base 7 over here equal to a log base 7 over there. So what is this going to condense to? Do you see the subtraction sign? That means there's going to be some division in here. This addition is going to change to multiplication. X times x over 3. Hold on. And so this is going to be, this addition is going to change to a multiplication. But how do we usually write over there x times x? X times x is equal to x squared. So this log is equal to that log, so we have x squared over 3 equal to 3 times 4. What is 3 times 4? Now, some people get a little bit anxious about solving this kind of problem, but if you make the 12 into a 12 over 1, is 12 over 1 equal to 12? It is, so you can change the 12 to a 12 over 1. Why would I want to do that? Now it looks like a proportion. Most people know that to solve a proportion, you cross multiply. Do you remember the words cross multiply? That means you multiply these terms together and you multiply those terms together. So x squared is going to be equal to 36. 3 times 12 is 36. I'm solving for x. What am I going to do about the 2? The answer is 6. If you have an equation with logs on both sides, I need to condense it so I have log base 8 on both sides. This is subtraction, so it is going to change to division. This is 48 over x. 48 over x equals 4. Because this log is equal to that log, then this has to be equal to 4. The easiest way to solve that is think of 4 as being 4 over 1, because 4 over 1 is equal to 4. Then it is a proportion, then you can cross multiply. And so if you cross multiply, you have 4x equal to 48. Can you solve that? It is very important that you understand that the log is not a number that can distribute. Some people want to start off a problem like this by trying to distribute the log. The log does not distribute. And so we have this log equal to that log, so we need this part equal to that part. We don't need to distribute the log. It doesn't distribute anyway. We need this part equal to that part. Can you solve it? let's see, I want to subtract a 3x and add a 12. Subtract a 3x and add a 12 to both sides of the equation. That will cancel the 3x's. That will cancel the 12. Divide by 5. Often, these problems will have fraction answers. Do not decimalize the answers. Leave the answers in fraction form, and there will often be fraction answers. In order to solve a log equation where you have logs on both sides, I need to get 1 log on the left equal to 1 log on the right. In order to do that, I'm going to have to condense. This subtraction is going to change into division. Do you have any questions about that step? Do you know how I got that step? I don't see any questions. What?
Will there ever be like different logs,
Yes, you can have a problem with different logs. We will cover that on a different day. We're going to cover the kind that have the same base, and then later on we'll talk about, well, what do we do if it has different bases? But we're not going to do all of that in one day. Come back tomorrow and, oh, never mind. That's what we did over here, I believe. This question is, what if you have 2 logs on one side and 1 log on the other? You still condense it on this side. Tomorrow, we're going to talk about what if we just have 1 log, and then the other side is a number. But let's see. Let's get back to this problem. Okay, what are we going to do with this 1/2? That becomes the exponent. This 2 becomes the exponent. This subtraction means I'm going to divide 36 raised to the 1/2 power by 2 squared. What is 36 raised to the 1/2 power? And that is equal to 6, because a 1/2 power is the same as a square root. And so what is 2 squared? 2 squared is 4, and this log is equal to that log, so that means 2x plus 1 over x plus 5 equals 6 over 4. Now, that looks kind of Did I change? Oh, yes, I changed it in the middle of the problem. This right here should be a -1. Okay, I didn't change any other signs, did I? Okay, see the 6 over 4? The 6 over 4 will reduce. You can reduce it, or you can solve it with the 6 over 4. Because it is a proportion, you can solve it by cross multiplication. So if you cross multiply, you will have 6. Ooh, I don't want to use that. You will have 6 times x plus 5 equal to 4 times 2x minus 1. Can you solve that? What do you do with the 6? Distribute. What do you do with the 4? Distribute. And solve. I'm going to subtract 6x from both sides, and I'm going to add 4 to both sides. Cancel the 6x. cancels the 4, divide by 2, and x equals 17. If I reduce this to 3 over 2, in this step right here, I would have smaller numbers, but I would get to the same answer in the end. So if you choose, you can reduce that to lowest terms, and you'll get to the same answer. And so that concludes your notes for today.